All right, this question, it says the table shown represents two functions, function A and function B. So when you take this on the computer, you are going to see some drop-down menus. I would encourage you to click on those buttons to see what types of choices you're looking at, because that's going to help you maybe decide how to approach the problem. Because if I were to click on this box and this box, I would see that my drop downs are going to be linearly and exponentially. So I know I'm trying to figure out if these functions are increasing linear or increasing exponentially. So I got to think about what that means. When I have a linear function, I'm either going to be adding or subtracting as I go down my list. When I have an exponential function, I'm either going to be multiplying or dividing as I go down my list. Okay, now if we notice here these x values, they're not the same. They don't go up by the same amount every time. It goes from 0 to 1 to 10 to 20. So that might make it a little bit tricky. If these were all in order and like it went 0, 1, 2, 3, it would be nice and easy to see what was happening. I can tell from 0 to 1 that I went up by 50. But then this part might be a little tricky to see what my change was. So because I'm not going from 1 to 2, I'm going all the way from 1 to 10. So one suggestion you could try if you wanted to make it a little bit easier on yourself, you could make a list. So if I go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I fill in, this is 700, this is 750, it looks like I'm going up by 50s, right? So then this would be 800, 850, 900, 950, 1000, 1050, 1100, 1150, and then 1200. Is 10 at 1200? It is. So that was the right pattern, was that I was increasing by 50 every time. So here I add 50. So this is going to be linear. So function A is linearly. Okay. Function B, here it looks like I add 24. So if I do that pattern, if I add 24 every time, so I'm at 600, I'm at 624, I'm going to be at 648, and then I'm going to go to 672, 696, 720, 744, 768, 792, 816, and let me line these up better. And I'm at 840. I was supposed to get to 888. Adding is not what's happening. So now I got to figure out, if I'm not adding, I'm not getting smaller, so I'm not subtracting. I'm not getting smaller, so I'm not dividing, so I got to be multiplying. If I'm multiplying, it's going to be exponential. So I've ruled out adding, subtracting, and dividing. So I'm pretty confident it's multiplying. If I wanted to double check, to figure out what number you're multiplying by, you work backwards. You say 624 divided by 600. And I get 1.04. So that's the number I would multiply by. See how that works? If I do 600 times 1.04, gives me 624. And then I would go down my list. So I would hit times 1.04, and I get 648.96 times 1.04, and I get 67491 times 1.04, and I'm at 701.91. And I keep going, so I'm at 729.99, 759, 789.56, 790.599, 822.22, and now I'm at 855. Oh no, what happened? Oh, I started one line off? Nope. Alright, I must have typed something wrong right here. So from this one, it's 1.04, and then this one was off. It was 821.14, and then it was 853.99, and then 888.15. Okay, so I just had to double check myself. I typed the wrong button in somewhere. So here I ended up at the 888 that we were supposed to. Okay, you did not have to double check because you did eliminate, but if you just wanted to see, that's how you get there. So this one was going to be exponentially. So when you have exponential functions, right now at this 10th day, or 10th, whatever this may be, function B is smaller than function A. And even at day 20, function B is smaller. But when you have exponential functions, eventually the exponential will be higher than the linear function. They'll exceed those values. So here, we're going to fill in as x increases, so as our x values get bigger, the quantities for function B will eventually exceed the quantities for function A. Okay, so which one will eventually be bigger? It's function B. And that's going to be for any exponential function when you're comparing it to linear. Because exponential functions increase at a faster rate. So like linear might be higher for a while, like all of these values, linear is higher. But linear is going to end up right here, starting to be less than the exponential function. Okay, so eventually as time goes on, the exponentials will exceed the values for linears.